Hi everyone, welcome back to SD Online channel. I hope everyone is doing well, good and healthy. So already we have discussed so much fine. We already started our routing and we have already discussed static routing, dynamic routing as well as default routing. So if someone is asking for you which protocol we are using for the internet, you can say this we are using for the by default routing. So now in this video we'll talk about what is the distance vector routing protocol, what is the link state routing protocol. So overall routing protocol is depend upon these, what are the algorithm they are using. So that's what we're going to talk in this video. So let's start. What is the classification of routing algorithm? You already know about what is the routing and how it is working. So let's take example all RIP protocol, EHRP protocol, Border Gateway Protocol, BGP protocol, Open Shorted Path First protocol. That's all protocol will be coming here. So let me, okay, here we'll use ISIS, we can see. But before starting, let's discuss about what is the distance vector routing protocol, what is the link state routing, what algorithm they are using. So let's start first information what we have. Let me open the pointer. The first is routers and information about directly connected network. Means who is the neighbor of this particular router, he can send all routing information to that router. Instead of the what is the link state, it is the wrong, but what is the link state routing? Instead of this sending the neighbor router, it is sending all topology. Means that is the things is happening because routing table information can change between the neighbor in distance vector, but in link state it is changing overall topology which is there into the network. That's what it is, the slow conversion, and that is the fast conversion we are getting. And they are using which one? Bellman for algorithm and link state routing using for the Disgust algorithm. That is, we'll talk about how they are calculating the cost, how they are calculating to reach the destination. So we'll definitely look into this. And the traffic is less, and as compared to distance vector, link state routing provide the traffic is more because they are using the shortest path first. That algorithm they are following, and they are that's what distance vector having the lower CPU memory uses, and link state routing having higher CPU memory uses, because what are the routing information changes is happening, they are sending overall in topology. And that's what here infinity problem will count, and here will not get any com. And here looping problem will be going to do, will be happen into the distance vector routing protocol, but will not see any loop problem into the link state routing protocol. So make sure what you need to think about in distance vector routing, the information if I want to change, okay, so what, I'll be sending the routing information one router to another, not for the others. But what happened into the link state routing? Link state routing, I'll be sending for all what are the topology I have. So we'll talk about some example. So the example is for this distance vector routing, we are using RIP protocol, HIP protocol, BGP protocol, and link state routing we are using for IC as well as OSPF. So we'll go into that way how the calculation happen into the distance. So where here I want to take the example of the distance vector routing protocol. Okay, so I'll be going to that way, that is A, B router, C router, D router and A router. So we'll discussing about which, so let's take example, the distance is 5, A to D it's 7, C to D we can say that 6, it's 4, and let's take example B to A also I can calculate, and I can go ahead and I'll mention into the 8. Now I want to router A. I'll be taking router A. How the routing information will be going to change. So I'll be using this one destination, then distance, okay, and last one should be hop. Okay. Now I'll be taking the A. If I want to go A to A, what is distance for this one? It's 0, right? A to A. I want to go A to A. That is means already 0. But let's take example. I want to go B, C, D, and last one is E. Okay. I want to go B. I don't see any connection A to B. So I will, what is distance here? I will mention infinity. Similar, A to C, I don't see any connection to between A to C. So that is also coming under the infinity. Similar way, A to D, I don't see any connection directly A to D. So it is there via E, but this will go into the next things. And what about E? A to E, my distance is what? How much? 5. And that is comes under the my A hop. That is calculation is happening between how you will be going to be. Now let's take example, you are going to be connection between A to E, but what is the router A, how connection between A to E? Only 5, right? So that is connection will be happening, and if they are not connected to each other, that is totally going to be infinity. So that is I have updated the node A. Similar way, if I am going to be E, if I am going to be E also, let me let me create the new tab as well. Now let's take example. I want to for E. So similar topology I can use, and distance can be changed. I'm not remember the exact distance what we are using for other. Okay. Uh, 5, 7, 6, 4, 8, and A, B, C, and D. Now we already calculated for which one? A we are calculated. Now we'll calculate for node A. So first my destination, okay, then distance, and last one is hop. Okay, and similar way I'll be putting the table A, B, C, D, E, right? So if I'm talking about the E, E to A, what is distance? Already we calculated how much? 5. B to E, right? It's A. C to E, there is no direct connection. So that's what is going to infinity. D to E, it's there. How much? 7. And E to E, it's 0 cause there is no distance and it is going to be E. That is all connection will be happening to the in calculation while going to be node A, node B. So that's what A connected directly to E. So what are the routing information? Router A have directly changing to router E. Then E will be sending to the D and B. Then B will be sending to the C. And C will be sending. So that's what it will take time to change their routing part. You got this point? So that is distance vector protocol. And if you are talking about the how many distance they have, how many distance they have, that is calculating. And what are the information they have, they will be changing to the their neighbor router only, because router have the information directly connected network. And what are the routing information have? So here router A directly not sending to router B, the routing information. That's why we have mentioned the infinity. E is not sending to directly C. What they are doing, each and every network, what they have in connected, they will be sending the information to that, and that is taking the slow conversion because they are sending one router information to another directly connected. And if you have the big topology, so that will take the time. That is calculation happen into the distance vector protocol. And now let's take example. If I want to update A, now I have update distance, but if I am going to update node A, let's take example node A. Now node A, if I am going to node A to D, how many distance will be going? 7 plus 5, it's 12, right? Then again A to B, 5 plus 8, 13. That information is going to be updated each and every time. So that is happening into the distance vector. They are sending the routing information to directly connected the network. So I hope you got this point. Now we'll coming up to link state. Already I have mentioned the information they are directly sending overall topology. So they are not waiting for the other things. Let's take example. Uh, A to E, B, C, D. I have 1, 2, 1, 1, 3. Okay. The link state routing, what they are doing, the distance in link state routing, they are choosing which discrete algorithm. And what is this algorithm? That is O shorted path first. That means, let's take example. I want to connect A to D. How many? 1 plus 2. How many distance I have? 3. And I want to use this path. How much we have? 1 to 1, 1 plus 1 plus 3. That is 5. So by default, the information directly sending within the topology within a 8 B, C, D, E router, which is there into network topology, and they are directly choosing what? Okay, this path is going good to reach the packet to A destination. So by default, they are using this by using this method, the algorithm, they are directly selecting the path. That is happening. That is happening for the shortest path first into leg state. That is very, very fast conversion you will get. So that is difference between distance vector protocol and link state protocol. In distance vector, the main thing is there. How many distance you have, they will be changing for the neighbor only. But in link state, what are the information they have? They will be transferred, or they are sharing the all routing information within a topology. That's what they will be getting the information. Okay, this router having this only 1 plus 1 2 distance. Okay, this router having this. So that they are directly selecting the shortest path, and that will be getting the fast conversion, and definitely will get the good results. So that is happening into the link state and distance vector protocol. Uh, so that topology we can follow here in the distance vector and link state protocol. If you are wants to be any update, any calculation, that is also easy. You can do it. What the distance, and you can calculate the nodes as well. If you are update the nodes, which node via transfer, that we have already seen into A to D, direct connection was not there. So via E it's connected, and we have calculated the distance 5 plus 7, that 12, and that all information or node you will get the calculated. Similar way in link state also, that is all information by default is going to be calculated, which is the first in topology, which is the shortest path they will be taken directly. So that is overall distance vector and link state protocol, and this is the difference. So in interview, you will get question between distance vector and link state routing protocol, and definitely you can mention the main point here. In distance vector, it is changing the information within only neighbor, and in state what are the routing information they will be changing directly topology what they have. So That is the main difference. That's why they have slow conversion and fast conversion, and they are using the Wellman for algorithm. That is, I already explained how they are calculating the distance, then destination, and what are the, if they are not directly connect, we are counting as a infinity, and we are like, if router E don't have the information, router E will be sending the directly connected to neighbor. And similar, in they are using the discuss algorithm, that is the shortest path first, and that's what we are doing. And the best example of RIP, EIGRP, BGP, and link string is OSPF and ISIS. I hope the concept is clear now for distance vector routing protocol and link state routing protocol. We have one more video that is will be going to talk about the RIP version. So we'll connect shortly on this. If you're getting some knowledge from this video, please like and subscribe my channel. Thank you. Thank you so much.